My name's Angelo and I'm going to show you how to get started with HappyBrackets. First, open the project from within the HappyBrackets development kit that you downloaded. Click Open. Go to where you downloaded the development kit. Click on HappyBrackets Project, then press the Open button. Now we need to display the project window and the HappyBrackets tool windows. From the View menu, click Tool Windows, Project. Then from View menu, Tool Windows, HappyBrackets. The easiest way to start learning HappyBrackets is to run the examples. From the HappyBrackets menu, move down to Examples, Basic, then click helloworld.java. You'll see your code displayed here in the code editor. A very cool thing about the HappyBrackets development kit is that you can run your code in simulation mode, which is where we use the IDE to test and simulate your composition on your computer without even having to set up your Raspberry Pi. This is extremely convenient if you're doing your work while you commute, or you have an idea you want to test out, you're debugging, or you just want to try out HappyBrackets to see if it's for you before you decide to buy a Raspberry Pi. First, compile the code by right-clicking the mouse and selecting Recompile helloworld.java. This will compile the Java code and convert it into Java bytecode. Right-click on the file again and click Run helloworld.main. You will see the IDE begin to run the code. Once the code starts running, you should be able to hear a sine tone being played through your computer. Also, when in simulation mode, you'll see a window that displays the waveform. To stop the program in simulator mode, simply click on the red square Stop button or click Stop menu item under the Run menu. Now that we've simulated and heard what our composition is going to sound like, it's time to download it into our Raspberry Pi. If you look in the devices list in the HappyBrackets toolbar, you should see your device displayed. If you don't see it displayed, you need to check your network settings and make sure you're connected to the same network as your Raspberry Pi. Select your device by clicking on the row where the device appears. The device should become highlighted. Check that you're able to hear sound from your device by clicking on the button marked B, which means beep. If you hear a sound, this means that your Pi is connected and you'll be able to make sound. If you have lost connection with your Pi, the name displayed will have a line through it. So just check your network connections again. We can see now that the device is connected up. Click on the refresh button on the compositions window and you should see Hello World displayed on the compositions drop down. Click on the selected button below the Hello World. Your Raspberry Pi should now be making the sine tone similar to what you heard when you ran your composition in simulator mode. You can stop the sound by clicking on the R button, which means reset. Another way to download your composition is right-clicking on the editor or project window and selecting Send Hello World to your device. Also, you can select the file in the project window. Right-click and send it that way. So there you have it. You ran the first example in the Raspberry Pi with HappyBrackets. Let's do another example. From HappyBrackets, Examples, Sensor, Accelerometer, simpleaccelerometer.java. This composition plays a sine wave which is dependent upon the x value of an accelerometer. First, compile the code and then run it from within the simulator. You'll see a window that says Simulation on the screen. What this does, it allows us to simulate the accelerometer. You can see that the frequency changes when I vary the X value of the accelerometer. Again, press the stop button to exit simulation mode. Now download the composition to your device. You can hear how the frequency changes as I tilt the X-axis of the accelerometer. Again, press the reset button to stop. In our next tutorial, I'll show you how easy it is to write your own composition from scratch, test it and run it on your Pi.